So this is called lesson 5 because I can kind of stick it anywhere. This is a math skill that we're going to use once in a while. This first unit is called math skills, and it's boring. It's not physics, but it's stuff I got to cover because of the curriculum. At the end of this unit, you're going to write a test. Well, really, I'm going to try and make it worth a quiz, but I'll count it as a test. It's kind of halfway between a quiz and a test. It's a quest. If a quiz and a test had a kid. Okay, and it's going to be on tomorrow's morning lesson, scientific notation, Monday's morning lesson, which is called sig figs or significant figures. Some of you may have done it last year if you did a Chem 11 course last year. Calculating percentage error, and then I'll do a lesson on unit conversion and unit analysis. It's dry, but it's handy skills, and so we're going to start with that today. Then we're going to get into the real physics, and yes, we'll look at free fall, and yes, I'll show you a video of me jumping out of an airplane. I mentioned I jumped out of an airplane and stuff like that. So often when we are completing a lab, this is called calculating percentage error. Often when we are completing a lab, we would like to know the accuracy or the validity of our results, especially if we know the answer that we're supposed to get. We do an activity where we try and calculate the acceleration due to gravity, and I know the answer you're supposed to get. If we have a known value to compare our lab results to, we can find out our absolute error and our percentage error. The absolute error is calculated really easy. Let's suppose the answer that you got was 12, and you know the correct answer is 16. You go 16 minus 12. 4. Don't go 12 minus 16. We don't count the absolute error as negative. A negative would just mean you were too low, but we typically report the absolute error as positive. So I wrote here mathematically, Riley, the absolute error is the theoretical or calculated or measured value. Take away the known or accepted value. And then I put, does anybody know what those two vertical bars mean? It's a math symbol.
Absolutely.
This is called absolute value. George, what's the absolute value of 5?
5.
What's the absolute value of 6?
6.
Very good. What's the absolute value of negative 5? 5. What's the absolute value of negative 6?
6.
The absolute value symbol simply means if your answer is negative, chuck the negative. Really, it's asking on the number line, how far are you from 0? I'm 6 away from 0 in either direction, not negative 6 away from 0. We don't report distances as negative. So this is saying you can go your theoretical value minus the correct value, or if you're really lazy, Deegan, just go bigger minus smaller, and it's always going to be positive. Okay? The known or accepted value is often, the question will say, the correct value. So absolute value just means make your answer positive, even if it's negative. In other words, just go, oh, that slide, bigger minus smaller. That gives you your absolute error. Then, if you want the percentage error, take the absolute error, 16 minus 12, 4, and divide it by the correct value. 16, and then multiply it by 100% to turn it into a percentage. Let's do a couple of examples. Police officer uses a radar gun to clock a passing Ferrari at 211 kilometers per hour. However, according to GPS measurements, the Ferrari was actually traveling at 199 kilometers per hour. Calculate the error in the officer's measurement. So what's the theoretical value? The value that was measured but is not correct. What's the known value? So what's the absolute error? It's going to be 211 take away 199, or 199 take away 211, but then take the absolute value of that to make it positive. So I just go bigger minus smaller. Double check me, 12, yes? Does that mean this radar gun will always be off by 12 kilometers per hour, no matter what speed the car is traveling? No. We would be more interested in the percentage error. So the percentage error, that's going to be the absolute error, 12, divided by the correct value. Which value is correct? And then you multiply it by 100 to turn it into a percent. I have no idea what this is. This is where you're going to start to use your calculators. I would encourage you, a good habit is to always follow along on your calculators. You'll develop calculator speed, which helps you on timed tests, in my mind. So I would encourage you, don't just sit, oh, watch Mr. Duke solve this. See if we get the same thing. Ethan, did you get 0.06? Oh, times 100. Did you get 6.03%? How accurate should I be? 6%? 6.0%? 6.03%? 6.030150754? Well, when we do our lesson on significant figures, that's where we'll say there are actually mathematical rules that tell you how accurate you're allowed to give an answer before it's nonsense. For now, I tend to go to 1 decimal place, so 6.0%. Anybody here do Chem 11 last year? So you did? So 2 sig figs. Does sig figs ring a bell? You did sig figs in Science 10? Oh, okay. Who was your teacher? Oh, he covered it? Well, good for him. That'll help you. Example 2. 2 people, Connor and Sheila, measure their weight in the morning by using typical bathroom scales. Bathroom scales are famously unreliable. They are not accurate. So the scale reports that Connor weighs 237 pounds, but he actually weighs 256 pounds. Sheila's scale reports her weight as 117 pounds, although she really weighs 129 pounds. Whose measurement incurred the greater absolute error? How are we going to figure that out? I think we're going to do a comparison. And so I want to be, you're going to hear me say this phrase, organized but lazy. I figure I'm going to divide this into roughly 3 gaps. Here, I'll figure out Connor's absolute error. Here, I'll figure out Sheila's absolute error. And then they want to know which one's greater. Here's where I'll actually answer the question. Oh, so-and-so's is bigger. Is that okay? So what would be a good abbreviation to use for Connor? I'm going to go C underline, S underline. And I encourage you, be organized but lazy, but be organized. So Connor's error is going to be 256, take away 237. 19? Double check me. Yes? What's the abbreviation for pounds? Why LB? What's that got to do with pounds? By the way, LB is falling out of favor because we now have a pound key that we call a pound key. You also call it a hashtag because, so anyways, you can also abbreviate pounds like that. Okay, Sheila, I'll change colors. It's going to be 129, take away 117, which is going to be 12, yes? Whose scale had the larger absolute error? I tend to put a box around my final answer so that Captain Obvious like me can find what my final answer is. Oh, that must mean that Connor's scale is less accurate than Sheila's. Well, no. We really should find out which one is off by a greater percentage. So, who had a greater percentage error? I'm going to do the same shtick. Divide my paper into 3. Same abbreves, Connor, Sheila. I'll write percentage for percentage error. And that's going to be 19 divided by which one? So Connor's is off by 7.4%. Compare that with Sheila's. Am I going to divide by 129 or 117? I've often wondered if they deliberately underscale bathroom scales because people might be more inclined to buy a scale that makes them appear less heavy. I don't know. %9.3%. I didn't bother multiplying by 100. I did that in my head. So, who has the greatest percentage error? Sheila. Did I spell Sheila E-I or I-E? E-I. I was right. The really, really inaccurate bathroom scales are the cheap ones that aren't electronic. This kind. These ones. I got 2 of them sitting here. We use them for experiments and we bang and beat on them. It's all good. Back on the shelf. Another place where there is almost always a huge percentage error is when governments estimate how much something will cost. So I didn't use a government for example 3, I used me. Mr. Dewick estimates that it will cost him $7,650 to rebuild his porch. The government estimates that it will cost X $100 million to build the Golden Ears Bridge. The actual cost is always significantly higher. So, calculate the absolute error. That's going to be 9,800 minus 7,650. I think I can do that in my head. It's going to be 1,000. Hang on. It's going to be 2,150? 2,150? What's the percentage error? The actual cost is 9,800. That tells you this is not a government, because usually government percentage error is about 100%. Seriously. Yeah. Part of it is typically the projects take a long time. So, for example, they're building a dam in the Peace River region, the Site C Dam. Well, they didn't anticipate COVID. Everything's going to be more expensive now because you have to build in all these safety protocols for the workers, and everything just gets more expensive. 21.9, if I go to 2 sig figs, I'll call that 22%. But if you said 21.9, I'm okay with that because you don't know how to do sig figs yet. So, we are going to do a mini lab on percentage error. Let me pause the video lesson.